Now for the next question, question F. Now if you go ahead and plug in negative infinity, I guess you'll get a form of indeterminate form, one of the indeterminate forms. So we have to solve it in another way. Let's see. Limit as x approaches to negative infinity of x squared plus 1. Now for the denominator, I can do a little trick here and take the x squared as a common factor. Now, as I said before, when you're taking a common factor, you have to divide every term by the term that you took as your common factor. So I took x squared, so I divide x squared on every term here. So x squared over x squared equals to 1 plus 4 over x squared. Okay, it's pretty simple, pretty basic algebra. So 1 plus 4 over x squared. Okay, now we have two terms multiplied by each other under a square root, so we can split the square root on these two terms, plus 1, so x squared times 1 plus 4 over x squared. Now, as I said before, this x squared equals to absolute of x. So we can substitute x squared plus 1 absolute of x. Instead of writing root of x squared, we'll write absolute of x multiplied by, now think about it, 1 plus 4 over x squared. As x approaches to negative infinity, to a very extremely large number. So if I put here a very large number, it would equal to 0, right? So let's try it out. 4 over negative 9, we'll get 0. So this part right here equals to 0 when x approaches to negative infinity. So 1 plus this part equals to 0 when x approaches to negative infinity. So 1 plus 0. Now, this function actually contains two functions in it in a certain condition. So positive x when x is greater than or equal to 0, and negative x when x is less than 0. Okay? In this case, x is going to negative infinity, and negative infinity is definitely less than 0, so we're picking the second function with a negative. So limit as x approaches to negative infinity, x squared plus 1 over negative x, and what's 1 plus 0 is it's 1, and root 1 is 1, so negative x in the denominator. Now, let's see. We'll take x, 1x. We'll take 1x from the numerator as a common factor, and as I said before, when taking a common factor, you have to divide all the terms by the sum that you took as a common factor. So x plus 1 over x, right? If I multiply it again, I'll get x squared plus x over x, 1. So I took x as a common factor, and the denominator is negative x. Now, the x's will cancel out, and I'm left with limit as x approaches to negative infinity of x plus 1 over x over negative 1. Now try to plug in negative infinity. This part will go to 0. Okay, this part will go to 0. So negative infinity plus 0 over negative 1. So negative infinity plus 0, negative infinity over negative 1, positive infinity, I'd say. So let's check our answer, and hopefully we got it right from first time. Calc negative 9. Yep, positive infinity. So that's the answer for question F.